Welcome to my YouTube channel. So in this particular video, we will be discussing about the greedy algorithms. Until so far, if you will be able to explore my playlist of DSA using Python, by the way, it's very matured now. We have covered up almost everything from a scratch till the advanced level of DSA in that particular playlist. But there is one topic which is still pending to cover up, and that is about the greedy algorithms. Until so far in that playlist, I have not covered up the concepts of greedy algorithms, why it is being used, right? So whenever we're talking about greedy algorithms, it's an optimization, you can say, problem wherever you want to find out the maxima or minima of any given problem. That is where we usually prefer to go for the greedy algorithm approach. There are so many applications of this algorithm that we have. So in the continuation of the next part of the video, you will observe that I am attaching the paid course recording, and I really want you all to, explore the context behind greedy algorithms. I think the way I have explained is you will be easily able to get that point. I have just fetched the recordings of that and is being uploaded on this particular channel as well, so that everyone can take advantage of this particular part. So without wasting any time, let's get started. But before that, please make sure that you will hit like button, you will subscribe this channel. Your support really means a lot to me. And there is one more announcement that, I have recently launched one new course on my website. You can go and explore and check it out. All the, details are already attached in the description of this video. The course is all about SQL Bootcamp. It's a 7-day bootcamp where I'll discuss everything from the scratch till the very advanced part of the SQL. And those who are already aware, SQL is something which is, necessity skill for every data domain, whether it be data scientist, data analyst, data engineer, right? SQL is something which everyone should know and is a part of every interview wherever you will go with respect to this data specific domain I'm talking about. So yeah, this is the information which I want to give to everyone. Now, without wasting any time, let's get started with the concept of greedy algorithms. So today we are trying to talk about the another algorithmic module, which is about the greedy algorithms. And binary search is an application of divide and conquer module. Okay. So greedy algorithms. Now, whether it's a greedy algorithm, and in future session, in the upcoming week, we will talk about a dynamic programming also. That is also a part of a algorithmic module. Both of these modules, whether it's a greedy algorithm, which is our current week focus, or the upcoming week focus, which is dynamic programming, that was the last week number 8, where we will discuss the complete dynamic programming and its applications. Both of them are usually designed to solve any optimization problems. Optimization problems. Now, what is the meaning of optimization problems? Means any problem where you specifically need to find out the minima or the maxima. Minima or the maxima of any given problem, if you want to specifically find out, that is where we usually go for the optimization problems. Okay? Let me give you one simple example of this. For example, let's say that as of now, I am in Bangalore. Okay? And I want to reach from Bangalore to Delhi. Okay? So this is the source A and this is the destination B where I want to go. Now, if I'll ask you one problem statement, that what are the possible solutions that I have with respect to going from location A to location B? So what will be your answer? So how can I go from Bangalore to Delhi? What are the possible solutions that we have? Any answer? Can anyone give me?
So you can go by road, you can go by railway, you can go by flight,
Correct.
Everything has its own costs.
So one solution can be we can go via own road, right? Another solution can be we can prefer to go via flight. Another solution can be we can go via maybe train. Another solution can be we can go via bus, on road, or by saying that by drive. People usually do that, right? So let's say there are four possible solutions we have. This is something which, in terms of a greedy algorithms, is called as a solution space. This is a term which is given by researchers when they design the solution of any given problem. So, given any problem statement, whatever be the solutions which you think can be possible with respect to that problem, that comes under the category of a solution space. So, for this, you are saying that maybe you can say via bike as well, we can go if we want to go. People usually go do a ride as well. And if we have several days to reach, then maybe by cycling. So, whatever be the thing which is coming in your head will become your solution space. Whatever be the name solutions which you can think of to go from point A to point B, all these are the solution spaces that we have. Now, given these solution space, now I will say that, I will provide you one constraint. And the constraint maybe, I will say that, I'm looking for that solution which is giving me a minimum cost. Minimum cost. So I have given you one constraint as such. Now, minimum cost is the constraint. With respect to that part, can I say that flight is not a good option because it will take the highest price? Maybe bike, cycling, or bus or train. Even this drive part, if we are driving by our own car, it will take too much petrol maybe and will not be a good solution, right? We want a cheapest solution. So maybe we'll go via, even bus ticket is also expensive as comparable to train. Now, let's say I came to a point where I'm thinking that these three are the ones which which is requiring a very least amount of a cost, let's say. So these three you will categorize as another term as feasible solutions. Feasible solutions. Okay. So second term is feasible solution. Solution space is a set of all the solutions which you have. Out of these solutions, the solution which is determining that constraint as well, considering the constraint as well, whatever the solutions you are approaching, you will categorize it as a feasible solution. Make sense? You will categorize it as a feasible solution. Now, apart from this feasible solution, let's say I will say I want to reach within minimum cost and minimum time. Now I have made it more stricter that cost is also minimum, time is also minimum. So maybe I'll prefer to go via train because bike and cycling will take too much time. Out of the feasible solution, I will go for a single solution, and that solution I will categorize it as a optimized solution. Optimized solution. So always remember that there can be multiple feasible solutions for a given problem, but there will always be a single optimized solution which you will print as an output, which you will deliver. So to get that single optimized solution, we always go for either greedy algorithm or we will go for a dynamic programming. Now, what is the difference between these two approaches? That is a different talk. But as of now, you have to understand what is the meaning of the term called optimization problems. Is this clear to everyone? Three important terms I have talked about. First thing is solution space. Second thing is the meaning of a feasible solution. Third thing is the optimized solution. These three are the You can say algorithmic terms, which you should know. If let's say in future you want to go for a research side, you will heard these terms quite a lot in algorithms part. Is this clear to everyone? Any doubt in these terms?
So, yeah, yeah. Can you define like optimized solution again,
So the
or at
simple
least
meaning of
yeah.
optimized solution is that it is following your all the constraints. For example, I have given one more constraint which is given to you, minima of time. I'm looking for a minima time required to reach. Already one condition is given to you, which is the cost part. With respect to this condition, you have already find out the feasible solutions. There are three feasible solutions, which let's say is giving me a minimum cost. Train will not take too much heavy price for me, biking also and cycling also. Cheapest one is cycling, let's say. But now the another constraint which interviewer or problem statement is giving to us is the minimum time which we have to look for. And when this constraint came into picture, when minima time, automatically I will say biking and cycling is not possible. I always left with a single solution. And that single solution is the most optimized solution that we have. So the difference between a feasible solution and optimized solution is feasible solution can be more than one. But optimized solution will always be a single solution that I'm looking for, which you really want to find out. Is this
So
clear
I
now?
have one question here.
Yes,
I
please
have one
ask.
question here. So here like I get that the optimized solution is taking care of all the constraints, but then
Yes.
again, feasible solution. Then what is the like if the interviewer asks me, okay, you are saying that the optimized solution is taking care of constraints, but you are also saying feasible solution is also taking care of constraints. But here is the only difference that feasible solutions takes care of one single constraint or
Yes.
like
Feasible solution will
okay.
take care of only this constraint, minimum cost. This will be given to you in the problem statement itself. Now,
Mhm.
this thing can be changed. This last constraint can be changed. Above constraint is valid. It's already available in the problem statement. This constraint will be changed. This can be changed, or I would say mutable. And depending upon this constraint, your optimized solution will always keep on changing. And this constraint will help you to figure it out that out of all these feasible solutions, which will be the most optimized solution. Is this clear now?
Yeah.
I'll try to provide you a few more. Today we will discuss applications also, then you will get a better idea. But as of now, the clarity between this, I have given just a layman example as of now, but I'll try to give you further more examples with respect to the greedy algorithms, which we are trying to solve here, right? In the upcoming session, we will also discuss the applications only. Another example, in terms of graphical interpretation, if I'll try to explain to you, what I'm referring here as a layman term example is, um, how many of you are aware about convex curve and non-convex curve in mathematics? Yes or no? Otherwise, again, I'll go deep down into a more layman example. Do you have an idea about mathematical curves of convex and non-convex? Or shall I change my example?
No,
I
Priya, what
mean,
was
Okay. Um, Acha, what is this called as? Have you
parabola?
guys, at least this thing you guys should know because this is 11th, 12th maths,
Parabola.
yeah, it's
parabola, right?
uh,
This kind of curve is called as a convex curve. Okay? Where we usually have a single local minima
minimum.
or global minima. If I'll ask you in this case, what is the local minima and what is the global minima? Any answer?
In this case, both are same.
Both are
Both are
same.
same,
Yeah.
meaning this is the minimum point. When I'm saying global minima, that out of all the curve which you are seeing here as a parabola, what is the lowest minimum point I'm talking about in a layman term? And you will see that this is the lowest point. Can I say everyone, this is the lowest point, green mark? If I try to create this kind of a curve now, And in this curve, if I'll ask you, what is the global minima?
The point at very bottom.
Again, the answer will remain same, that you will say this is the global minimum. When I'm saying the word global minima, it simply indicates that out of the complete curve that you have designed, what is the lowest point? What is the lowest point as per this y-axis which you are seeing, and as per this x-axis, what is the point that you are finding out? Let's say the value of this is 5 and this is, let's say, 2. I'm randomly writing it. So you will say 5,2 is the point which is giving me a global minima. Now, any curve which is having single local and global minima, means the local and the global minima is same, or a single one global minima is there, this kind of curve is called as convex curve. Okay? And for the curve which is having multiple local minima is called as non-convex curve. Those who are from machine learning background or data science background, they will be easily able to
Gradient.
understand this fact.
Looks
Yes,
like
anyone
gradient.
who is from this background?
It
No,
looks like
but I
gradient.
kind of gradient is, yeah. I mean, we try to like avoid the local getting stuck in the local minima, I think.
Yes, correct. So basically, what is the meaning of local minima? For example, if I start from this point, at this point, I feel like this is the local minima. But when I move down, this is the local minima. When I move down, this will come out, right? And then obviously, if I'll move up, this is the bigger value. So this is the final local minima and the global minima at after some point of time. When I'm saying locally means at every point, at every spot, my local minima keeps on changing depending upon the value which I'm getting here. Now, our focus in either greedy algorithms or either in dynamic programming is to find out a global minima. Okay? Is to find out a global minima. And that global minima is the optimized solution which I'm talking about. That's why I told you, our optimized solution will always be single, one. But feasible solution can be many. What is the meaning of a feasible solution in this curve? If I try to explain, this can be a feasible solution. This can be a feasible solution. This can be a feasible solution. But optimized solution will be always be the minimum value which I'm getting, which is the global minima that I have. Again, I am repeating at the same point. Feasible solutions can be many, but global minima or optimized solution will be only one. That kind of problem we will be able to solve via greedy algorithms and dynamic programming. Graphically, is it clear what I'm trying to convey here? Meaning of feasible solutions and optimized solution. ठीक है. Now, usually what happens is that this greedy algorithm can give us an optimized solution in not many applications. But still, there are few applications in which greedy algorithms fail. And they just give us a local minima and will not able to give us a global minima. That's where dynamic programming came into picture. That's why the need of DP came into picture. So for few applications, greedy works perfectly fine. For example, what are those applications? Let me try to talk about that as well. Applications of greedy algorithms, where they are doing actually a very great job and we're getting a correct output as well. The most common example is to find out the shortest path when you are moving from place A to place B that you are using on a daily basis. I hope you guys are using maps at any point of time. If you are in a new place, we usually have a habit nowadays, right, to just open our maps and try to see, write the destination where we want to reach, and then just our maps will show us the path, and even driver in the cab also is following the same path to help us to reach to that destination point, which is which will be anything, D, let's say. Internally, the application of greedy algorithm is working there. Now, again, they are trying to give us a most optimized solution. And what is the optimization they are doing internally? To give us the, anyone who can help me to let me know?
In time and distance both.
Correct. Minimum time, because no one is having so much of time to waste, right? Nowadays, specifically, I'm saying no one is patient enough to wait for so long in the cab. So minimum time is the very first constraint which they are looking for. And the second thing is minimum distance. For example, if let's say there is a position A and I want to go from position A to position B in Bangalore. Okay. So let's say I am in Whitefield area in Bangalore and I need to go to HSR layout. Okay, in Bangalore to travel to do the workshop, let's say. So this is the point A, this is the point B, and I usually take a cab from reaching to point A to point B. Now, the first constraint, the feasible solution can be many, depending upon the distance factor. So there can be a multiple routes to move from Whitefield to the HSR layout. There are multiple ways in Bangalore. Let's say it's a path A or X. This is the path Y. This is the path Z. So there can be multiple distance, multiple ways to go from A area to area number B. Now, what I want is, my constraint is that I want the driver to, help me out to reach to location B, which is HSR layout, in the minimum time. Now, again, you can see minima came into picture, right? Either you are looking for some minimum value or maximum value in optimization problems. So what you are saying is, I want in a minimum time to go from location Whitefield to HSR layout. So in that case, tell me out of this X, Y, and Z, which is having a lesser traffic and will be able to help me to go from this Whitefield area to HSR layout. And let's say my map is giving me this kind of a response. So my driver will take only this path to figure it out and to help me from going to A to B. And that is where our complete maps, Google Maps, is being designed. Internally, they are using something called as Dijkstra's algorithm to figure it out, the shortest path from moving to the location A to the location B. Is this clear to everyone? The very first, very interesting application. In real time, everyone is using this application. Internal thing is greedy algorithm, which is working upon to give us that optimized result. So what I want is, I want a single optimized path out of the possible paths, out of the feasible paths. So X, Y, Z comes under the category of feasible solutions. Out of these, single optimized path I am looking for, which give me a minimum time. Is this clear, everyone? Any doubt in this part? Second application can be the job scheduling. How many of you have studied about in an operating system,
Yeah.
there is a job scheduling algorithms that we have, right?
Yeah, shortest
Yes.
of first
Round robin.
or
Shortest job
round
first,
robin.
round robin. Yes. There are so many algorithms we have internally, right? To schedule the job. Now, how basically internally the job are scheduled as per the deadline of the jobs in order to gain the maximum profit, in order to utilize it maximally the OS system, the jobs that we have. Again, greedy algorithms are working internally. We'll discuss all these applications, whatever, by the way, I'm saying here theoretically today, as it's a very first session. I'm just trying to give you a glimpse of what are the applications we have. Step by step, we will discuss each and every application and we'll do the implementation of every application as well. Okay? Apart from this, there is a concept of fractional knapsack. I don't know how many of you are aware about this knapsack problem. Again, a very famous problem. which is a very famous again application of greedy algorithms. And we'll start our discussion of today's class from this fractional knapsack application itself. So I'll, within a few minutes, discuss about this problem statement, and then we'll discuss step-by-step solution for the same. So these are the applications of greedy algorithms that we have, which is basically help us to find out the optimized path. Again, there is another application of Huffman coding you will see, which is basically used for any idea?
Yeah, Huffman coding is used for error detection in messages.
No,
Data
it is used for
compression.
data compression.
Okay. Mhm.
So I hope you already are aware. For example, if let's say I will be having a very big file and I want to share that file to someone. In an email, there is a limitation of the size. If your file size is bigger than that, you won't be able to share. Although you have other options like upload in the drive and then share and so on. But let's say you want to, it's a very confidential file and you don't want to upload it in a drive itself. You want to share it via mail only. That is where what you usually do, you try to convert that file in the zip format, .zip format. Am I saying it correctly? So what happens is, in this format, you are compressing your same file. And then again, once you compress this file and you are mailing it to someone, they will just decompress that particular file and then they will be able to get the original data that you're trying to share. Does that happen? Everyone? I hope everyone is aware about all these basic things. They must have done that, but you might not be aware that what is the internal thing going on here, right? So the internal algorithm which is working in this data compression part is Huffman coding. So at any point of time, wherever you want to compress your data, if you will see the internals of that, this is just one example I have given you. There are multiple applications. Wherever you feel that there is a tool, even online also, you will find several tools to compress the data, to compress the images. Let's say you are having a very high quality pixel image, and let's say you want to decompress that. Usually we do in computer vision tasks. In that case, again, internally, this Huffman coding algorithm is working on. So how it is basically trying to compress our data? Again, Huffman coding is the one which is there. Similarly, there is an algorithm called as optimal merge pattern. Optimal merge pattern. I hope you are aware about the tool of PDF. What is that? Not converter.
I love PDF.
No. PDF merger. So let's say I will provide you 3 PDFs, okay? And I want to merge all those 3 PDFs in one go. That's the basic application which we usually does, right? For example, I will be having multiple files and I want to create a whole document for that. So what usually happens, if you will go to the online website to merge those, you will be able to get one link. If you will click on that, they will say that please upload all the files which you want to merge. Once you upload that, click on the download button, you will be able to get the combined version of the complete PDF of all the files, merged files you will be able to get. So optimal merge pattern is the algorithm which is working internally to merge those PDFs. Again, an application of greedy algorithm. We can merge it in any manner, but to get the minimum time and the space complexity, greedy algorithm is the one which is working internally. So whichever website or platform is giving us a combined merged PDF in a minimum time, you can consider that this algorithm is working internally. If it is taking too much time in any website, it means that they are not using the optimized solution. They are not using the greedy algorithm technique in that. Make sense? So yes, all these are the applications which are important to understand as per the greedy algorithm part. Now, when we're talking about other stuffs, for example, you will see there is an application of 0-1 knapsack. You will see there is an application of matrix multiplication, which we are using quite frequently in our computer vision or deep learning project, where we are dealing with images. That's where greedy algorithm fails. Why? Because sometimes what happened is greedy algorithm is not exploring all the possible paths. It is being greedy. For example, what happens if we are having in any application non-convex curve? It feels like, okay, it is going down, down, down. It feels like it might not be a global minimum, and then it will move up and might consider that this is the one which is the best, and will forget about the previous thing. So whatever results we are getting in the local minima, it is not storing anywhere. And once it will go, this result is nowhere stored. And then this is the updated one which I will report. So sometimes what happened is that being greedy, as the name itself suggests, it is trying to be more greedy and will not focus on the global minima which we already have, and will try to find in search of more local minima that we will be able to get. And once it will be able to get rid of this, there is nowhere it is storing any solution of whatever task this algorithm is doing, and it is completely vanished. Why DP is better? Why dynamic programming is better? What dynamic programming is doing? Dynamic programming is solving the same problem, as I always say, to solve the optimized problem. But what it says is that I will explore, first of all the possible paths. All the possible paths I will explore. And when I'm exploring the possible paths, I will save all the intermediate results, so that I will not forget. If I have to went back to refer any result, I can go back because I'm saving all the intermediate results. So what is happening in DP is taking some extra space in order to save all those intermediate results. But by increasing the extra space, it is helping us to reduce the time complexity, because it is able to give me a most optimized solution. Do you remember the very first session where I have talked about the time and the space complexity and its trade-off? I told you that at any point of time, if you will feel like that by increasing the space, extra space in your system, in your algorithm, if you can somehow able to reduce the time complexity, then it's worth it. Go for that. DP is the example for that. All the applications of DP, you will observe that it is somehow taking the extra space to store the results, which we might not use as well, but still it is storing that, so that in future, the problem of greedy was facing, DP will not face, and it will be able to always give us the correct result. So DP will always provide you the correct result. Always provide the most optimized solution. In greedy, you cannot guarantee. For few applications, it is working the best. But for few applications, it is not working the best way, and it is failing as well. Okay? So that is the basic difference. Remaining things, when we start discussing about the applications of DP, you will get a better idea. But as of now, that is the overall picture, or I would say basic fundamental of a greedy algorithm. Now, if you have any doubt in the fundamental aspect, you can ask from me. Otherwise, we will jump towards the very first application of greedy, which we will discuss today. And that is about the fractional knapsack. From here, we will start. And then step by step, we will move ahead to the advanced applications as well.
Priya,
Any doubt? Yeah, please.
So greedy does not use the extra space, is it?
Yes.
Okay.
Greedy is not storing the results. Greedy is just giving you the direct final result. But in DP, it is storing, for example, if I will apply the DP algorithm here, it is storing all the local minima results as well. So at any point of time, if let's say my algorithm iteration is moving up, my DP will compare that, okay, it is not better than the previous one. So it will stop and give me the previous result. But in greedy, if you will do the same thing, there is no previous result is saved. So it will only having the option to just give either this result or reiterate it back and then give the previous result. Okay? So DP will take more space as comparable to greedy algorithm application, but at the cost of giving us a better optimized solution in all the cases. But in greedy, few cases it will work best, few cases it will work worst.
And time for both is same, is it? Time complexity.
If the solution is not correct, if the optimized solution is not correct, then what will you do with the time complexity?
Okay. Makes
Right?
sense.
The first task is to get the correct answer. Second task is to figure it out in a minimum time. So whatever applications I have mentioned here, with respect to these applications, it is giving us a minimum time complexity. That's why people are using it today. That's why it is being used in the industry as well, to get the shortest path, to get the job scheduling done. But for those applications where it is not giving us a optimized solution correctly, we are not even trying that. We are just directly jumping towards DP itself.
Okay, got it.
Okay? Any other doubt? Anyone? Or everything is sorted till so far?
Yeah, I think.
Okay. So let's start with the very first application, which is about a fractional knapsack. Try to understand the problem statement very carefully. Then think over it, how we can solve it. And then at the very end, we will figure it out the solution. And then we will try to implement it as well in Python. Okay. This is how the flow will go for every application. So let's start discussing about the very first application, which is a fractional knapsack. So have you guys already aware about these things or are learning for the very first time? Whatever words or things I am saying today?
I have heard this before, but I don't remember.
And what about others?
I heard this concept for very first time. Fractional knapsack.
It's for the very
Yeah.
first time you are hearing.
Yes.
Okay. And what about Arijit?
Yeah, I have. It was part of our CS.
Okay. So you already aware.
One funny thing about fractional knapsack is if anyone plays video games, so there is this concept that you can carry a maximum of some unit volume. So, for example, you can carry maximum 20 units. And then you have like equipments. Say you have a bucket, you have a sword, whatever. Everything has a certain weight. It can be 5 units, 10 units. So since you can carry at max 20 units, you have to be selective in what you carry. And every item has its own value. So this knapsack concept, before even I got it in the CS, it was there in like video games basically. So yeah.
Perfect.
Anyway.
Perfect. And what about Roshan? First time. Okay. Perfect. So I think he already has said the problem statement, but let me state it again. Let's say we will be having few objects. Okay. And try to listen this problem. It's a very interesting problem. We have few objects. Let's say we will be having 7 objects. Object 1, object 2, object 3, 4, 5, 6. There is no space. Let me try to write N1, N2, N3, N4. N1, N2, N3, N4, N5, N6, and N7. For all these 7 objects that we have, you have the profit of all the objects as well as the weight of the objects that you have. The profit looks like 25, 75, 100, 50, 45, 90, and 30. And the weight looks like 5, 10, 12, 4, 7, 9, and 3. So this is how for every object, they are providing you the profit and the weight. Now, listen the problem statement very carefully. I'm giving you one constraint, and the constraint is that the maximum weight which you can carry is 37. Now, which items should I pick out of these 7 objects such that I will be able to get the maximum profit? Considering that the total weight which you will pick up, total weight of the objects should be either less than or equal to the value of capital M. It should not exceed with the value of M. It's something like, let's say you're going to a market and you will be having a bag which can only take a weight of, let's say, 37 kg. Okay. Now, I think it's a very big number I have said, but let's say 37 kg. Now, you went to the market and you need to buy the fruits, vegetables, groceries, and everything. Now, I'm saying, obviously, if your bag contains 37 kg, if you will push more than that, you will not able your bag will obviously be broken, right? Your bag will not able to take more than 37 kg weight. So that is the thing you need to take care of. Now the question is that which particular items you will buy so that you will be able to optimize your solution in such a way that you will be able to benefit more. Maybe you can also the items which are pending, maybe you can also take it via Instamart or grocery. You went to the physical shop or physical grocery shop just to buy only those products which are having maximum price and they're not cheap in the online store. So that is the mindset which you are taking up, right? So which particular items you will pick up, how will you decide? So that is how internally you will apply the kind of a greedy algorithm to make it a choice so that we will be able to get the maximum out of the grocery shop, right? Similar thing is happening here. You are giving the objects. For every object, you are giving a profit and a weight. Now, maximum weight of the objects which you can pick up is 37. You cannot go more than that. Okay? Now, a question I'm saying that out of all these N1, N2, N3, N4, N5, N6, N7 weight objects, which particular object you will pick up so that this constraint will also be satisfied and you will be able to get a maximum profit as well. Again, if you will be able to see, we have been given a constraint. You remember the first part which I talked about? Constraint is given to you, which will give you the feasible solutions. Optimal solution is meaning is that you need to find out a single solution, which will be the optimized solution, which will give you the maximum profit. So how can we go for this particular question? First of all, is the problem statement is clear to everyone? What I'm trying to convey here, especially for those who are listening for the very first time. Any doubt in the problem statement itself? Anyone? So I need to figure out now out of these 7 objects, which is given to me, which objects I will pick up so that I will be able to gain a maximum profit. And I need to satisfy the constraint as well, that my total weight which I will pick up should not be bigger than M. Is this fine?
Yes.
Now, how should I proceed?
One solution could be having objects N2, N3, N4 and N6.
N2, N3,
N4
N4,
and N6.
N6. Okay. So how you figured it out? These 4 answers?
Weight is less than the constant given, that is 37,
Hmm.
and the profit is more as
Okay.
compared to others.
Okay. Good. What about others? So if we will add these things, 10 plus 12 is 22. 22 plus 7, 29. 29
No,
plus 9,
I
38.
said N4. I said N4.
Okay, N4 you are saying. This one, N2, N3, N4 and N6.
Yes.
Okay. Again, let's add. 22 is fine. Plus 9 plus 4 is 13. So it will be 35. Still, you have a capability to take 2 kg more.
Now, what we can do is divide profit by weight and see whichever has the maximum number and keep on adding the weight until 37.
Correct. Correct. This is the correct approach. So what he said is, just think over it. So what Yashasvi said, that we can focus on seeing that what is the maximum profit we have and correspond to that what is the weight we have. We'll keep on adding until our value is less than 37. That's her approach. What Prajwal has said is a more wiser approach. We can't only focus on the profit and we can't only focus on the weight. Someone can say that just focus on the maximum profit. Whatever the maximum profit you're getting, take that first. That can be the one way. Now, some student can say to me that, Priya, no, not focus on profit, just wait on a minimum weight. So that maximum values, maximum items you can insert. Just go directly to 3. Take that. That cannot be also a possible wiser approach. Because both of them will be equally sensible to me. Taking the maximum profit or going for the minimum weight. Both are equally sensible. But individually, both individually, no one is correct. Like you can't go alone with the profit part or you can't go alone with the weight part. The wiser approach could be, you will say to me that, Priya, what you can do is, you get some number which will determine that what is the highest profit by weight value I will be able to get. So what you will do is, you will be getting that profit by weight value. Get that number. For example, in this case, what number you will be able to get?
5.
You will be able to get here 5. Here you will be able to get 7.5. What is the answer for this?
8.3.
8.3. For this, 12.5, I believe. For this, 6.4, 10, and 10. So what you have done is, in this case, in the last part, in the last row, you will observe you have tried to divide the profit by weight. And you get these numbers. Now, this is a good idea to check upon that which number is the highest number. So what you can do is, the first task is to get that profit by weight array or a list that you have. Once you're able to get that, try to sort the objects that you have in decreasing order. In decreasing order as per the profit by weight value. Why in decreasing order? Because whatever the higher profit by weight you have, that you will give as a highest priority to take. So once you will sort it out, N4 will come ahead. So what you will be able to get is N4. N4 value is 50. 4 is the weight. And this is the number which you will be able to get, profit by weight. After that, the second number will be, maybe you can say N6. What is the value? 99 and 10. Then N7.
N7. 30
right?
and 3.
33 and 10. Then next number would be
N3.
N3, right? 112 and 8.3. 112, 8.3. Then N2 is coming up.
7.5.
N2 is 75, 10,
10.
7.5. Then N5, right? 45, 7, and 6.4. And finally, N1, which is 25, 5, and 5. So what we have done is, we have tried to sort our objects with their profit by weight ratio. Does that make sense? Now it is very much clear to me that I will provide N4 as the highest priority. So I will take this object first. Let's say I will be having a new column by the name of fractions. So this value will be 1 because you're taking a complete N4 object. So what will happen? You know, maximum object you can entertain is 37, right? Maximum size. And let's say this is the profit which you're trying to calculate. And this is the net weight which you are trying to calculate. So what will be the profit if you will take N4 object into consideration? Profit will be 50 and weight will be, net weight will be 37 is the original weight which I can take. Now because I have included N4 here as an object, N4 is included. So 37, I need to subtract the weight of N4 which is 4. So I'll left with 33. Do you guys agree with me? Think over it. So what I'm doing as a third step after sorting it out, I'm saying take the objects in a sequential manner now because you have a sorted profit by weight value. And when you're taking up, just make sure your constraint is satisfied, which is total weight of the objects that you have. Yes, you can say XW considering the weights of the object, where I value will be 1 to whatever number you are taking up. This weight should be less than equals to 37, which is the value of capital M, right? So in this case, if you will be able to observe, we will be having a net profit as 50. Now we will move ahead to the next important object, sequential manner we are taking up. So this also I will take it fully because 9 is there as a weight and we have space. We have a space. So if I take after N4, the next object as N6, so what will be the net weight I will be left with? Yes, net weight I will be left with 33 minus 33 minus
9.
9. So what will be the answer?
24.
24. What is the profit? 20 plus
90.
90. Sorry, 50 plus 90. So what is the answer? 140. Can I say, everyone? Now, next weight, which next object is N7, which we will shortlist. Now, N4 is already there. N6 already we have taken. Now it is N7. So when we're picking up N7, again, we are picking up a whole object. It will be 1. Weight will be 3. So it will be 24 minus 3, which will be 21. It will be 140 plus what is the N7 profit? 30. So the answer will come out to be 170. Is this clear to everyone? Is this clear to everyone? Next object is N3. N3. So what will happen? Weight is 12. Again, I can take, right? 21 is the value which we have as of now. So what we can do, we can say 21 minus 12. It will come out to be N4, N6, N7. The fourth object which we have taken is N3. It will be 9. Can I say?
Yes.
What is the total profit? 170 plus
100.
100. So it will come out to be 270. Correct, everyone? I hope calculation is correct. Now, next point is interesting. If you will move to the next object, N2, it is having a weight of 10. But you are left with a pending weight as 9. So you cannot take the whole object. Can I say, everyone? Because our condition is we can't go ahead 37. Why this algorithm is called as fractional knapsack because you can take a fraction of the object portion as well. It's like when you are going to buy the groceries or the vegetables, you can take half kg, 200 gram of tomato as well, right? Similarly, here also you can take a fraction of the portion of the object. So if you will be having a net capacity of 9 and total weight is 10, in order to get that exact number, you can't go ahead with the 37. You can take a fraction, 9 fractions out of 10. So what you are saying, this is important here to understand. You are saying that I will take the N2 portion, but not fully. See, this until so far I am taking it fully, but N2 I am taking only 9 by 10th portion. So what you will do, you will say 9 minus, I am taking 9 by 10 into out of the complete portion that we had, this will come 0. And the total profit also, you will take 9 by 10th profit now with respect to the total profit that you have, which is 75 in this case. Just solve this. What answer you are getting? Take the calculator. Because when we will implement this, we will verify whether we are getting the same answer or not. So it's, I'm doing it via calculator, 270 plus 0.9 into 75. So, oh, sorry, 75. What I'm getting is 337.5. You can also verify. Is this correct? 337.5. So it means that this is the maximum profit which anyone will be able to take given the constraint that the net weight will not go beyond 37, capital M. And remaining N5 and N1, we will not choose. So it is 0. So if you will just add, let's say this is the value of Xi. So if you will just do the addition of this Xi value, where the value of I equals to 1 to N, let me remove this and write below, it will make more sense, will always be equal to the value of capital M in a fractional knapsack. If you will do the addition of Xi into W, it will always give you the maximum value of capital M. So you can try at your end, 4 into 1 plus 9 into 1 plus 3 into 1 plus 12 into 1 plus 10 into 9 by 10 plus 0 will give you the answer as 37. And that is the constraint that we have. So we are following this constraint, and following this constraint, in this condition number 3, we will be able to get the maximum profit. So at every time, what we are doing is we're taking the object and then trying to calculate the net weight. How? By doing a subtraction with the value of M minus the weight which we are picking up, W of I. Right? And in terms of profit, we are just doing an addition. So subtraction on the weight side, addition on the profit side, and this is how we will be able to get the maximum profit. Is this clear to everyone?
I haven't understood the calculation part of the last step.
So basically what I am saying here, this particular part which I am saying,
No. 9 minus 9 by 10 into 10. Why we are taking multiplied by 10?
So you are taking 9 by 10th portion out of this complete weight, which is given to you as 10.
Okay.
Now, similarly, you are taking a profit of 9 by 10th portion out of the total profit that you are taking up, 75. Okay? Is this clear to everyone?
Yes.
Any doubt now? Anyone? Taking the objects in a sequential manner and following the below task, which is subtracting the net weight and adding the profits. So these 3 steps composed of the calculation of fractional knapsack. What is that? First of all, we will try to do the profit by weight. Then we will try to sort those in a decreasing order. with respect to the profit by weight value, and then take those objects, select those objects step by step, decreasing the net weight and increasing the profit. And until or unless we will not able to get this constraint satisfied at any point of time, we will keep on going, right? When we will stop at that point where this value of xi into w will exceed the value of m. Correct, everyone? So if I'll ask you, what is the time complexity of this algorithm? What will you answer, depending upon the task which we are doing here?
O of n.
Any other answer?
But we have to sort first. So
In log n.
Yes. So it would be
yeah, it should be n log n, right?
Yeah.
correct. So basically, if you will go step by step, if you will see here, profit by weight calculation is n task. Sorting, we have talked about, right? If let's say we will apply the simplest algorithm of merge sort also, which is giving us in all the cases n log n, or if you will call direct function of dot sort, here you can call that function also in Python, because our focus is not to show the sort implementation from scratch. Our focus is to give the maximum profit. So even if you will apply dot sort function internally, merge sort is working upon, so it will be n log n. And then you are again taking the objects. So you will apply a for loop, right? And then you will do the below task. It will be again n complexity task. So if you will merge these three steps, it will be n plus n log n plus n. So overall complexity will become big O of n log n. Everyone agrees with me? The complexity will be big O of n log n. Any doubt in the complexity analysis part? Shall we move ahead with respect to the implementation? There is no doubt. We will try to take the same example. We'll try to solve it via implementation, the same approach which we will just now have written. And then we'll try to see whether we are getting a correct result of 337.5 or not. I'll write bit of code, then I will give you a few minutes to write further on top of that the logical part. And then we'll see mutually the correct exact implementation of the same. Correct, everyone? Shall we start? Shall we start?
Yes.
So what you can do is you can also open the Google Colab file, and I'm also opening it with me. I'll write few steps of code, and I'm sharing you the file link as well, which you can copy from my file, and then write on top of that your code. New notebook. Introduction to greedy algorithms and its applications. So today is you can say part 1 for the same. The very first application which we are discussing today is the fractional knapsack. Again, you will find this application in the collab as lead code as well. If you want, you can just try to solve the same thing in the Geeks for Geeks also might be there. You can just follow any of the platform wherever this application is given and you can check it out. Okay? Now, let's first of all write the driver code. And I'll try to take the same example intentionally so that we will be able to follow up the results as well. So if you will be able to see, we will be having one wait list which contains 5, 10, not 5, 10. Okay, it's a separate example.
I mean, it's 510 only, but it's sorted, no?
Oh,
It's
okay.
sorted.
5, 10. Then we will be having 12, 4, 7, 9, 3. 12, 4, 7, 9, 3. 7 objects. 1, 2, 3, 4, 5, 6, 7. Correct. Then we will be having a profit list. So I'm sharing you this file as well so that you can also copy anything which you want to copy. And then on top of that, you will start working on your file. In the chat window, I'm sharing. Okay. So we will be having a profit list also. Let me copy that as well. 25, 75, 25, 75. Then we have 100. Then what is the number? 50. Then
45,
45. Then
90, 90 and
90. Then 30.
30.
Right? Perfect. So this is the array that we have used, right? Now, the value of capital M, which is the capacity, which was 37, which we have used in our part, right? Now, what we are looking for is, we are looking for a maximum profit. And one more thing which I'm looking for is this fractional array. This one. Where is that? 1, 1, 1, 1, 9 by 10 and 0. Both of them I want as a result. Because these two are the important things, right? How my x of I will look like after the complete demonstration, and how my maximum profit will look like. So I'm looking for the two results here in my code part. One is the maximum profit, and the second thing is the fractions list or an array. Okay? For that, I'll call the function, which is a fractional knapsack. Okay? Now, this fractional knapsack will take 3 parameters. What is the profit? What is the weight? What is the value of capital M? And will return to me 2 results, maximum profit and fractions. So this is where I'm doing my function calling. Make sense, everyone? The last thing is the display of the results. Display of the results, which I want to look for, which I want to see. So I can print the maximum profit that can be carried in a knapsack is, and here we can just print the value of maximum profit variable. Similarly, I can print here the fractions in which the objects are taken in a knapsack is, and again here we can say fractions list we will pass here. Okay? Done? Sorted? Now the interesting thing will start. That is the function definition. Def, what is the function name? Fractional knapsack. I'm just copying it up. Inside this, we will be having 3 parameters. Profit, profit list, profit array, weight array, and the capital M, which is the maximum capacity of my knapsack. Now what I can do? Initially, I can initialize the list of fractions, which I will return with a 0 value. So I will say until my length of the profit, which will give me the size of the list that I have, I need to take off this fractions list, and I will initialize initially with a 0 value. Okay? After that, I will start working upon it. Similarly, I will try to specify the objects from N0, N1, N2, N3, N4. I have 7 objects. So I will take a list of the objects and I'll specify it in the form of from 0 to N minus 1. So I will say 0 to len of profit minus 1. So I have specified 2 lists here. One is a fractions list, which is initially initialized with 0. Another one is the objects naming, which is 0, 1, 2, 3, 4, 5, 6 in our case. Okay, it's a list. I have typecasted it. You can see, right? Now, what we have to do, the first task is to get the profit by weight ratio, right? So what we can do, we can try to get that ratio. You can apply the concept of list comprehension here. How many of you are aware about list comprehensions in Python? How many of you are not aware about list comprehensions in Python?
I'm aware, but I've not used it much. So
What about others?
Can we
Otherwise,
do
I have to first of all, because these things, to write a cleaner code, you can also do step by step also. That is fine. But in order to write a cleaner code, these list comprehensions, map functions in Python, right? These functions will be used. Map, filter, reduce, all the functions which are very widely used in Python just to clean your code, just to make your code very understandable. List comprehensions is one of them. For example, let me give you one simple example for that before we will write list comprehension to calculate the ratio part. Let's say I will give you one simple problem. I will say that, give me a squares of the, let's say, first 5 numbers, 0, 1, 2, 3, 4. Give me a list of squares of first 5 numbers from 0 to 4. You can also do via applying a for loop. You can also do via list comprehension. What you can say, I want a squares. So again, I'm repeating, my problem statement is, give me a list of squares of the numbers in the range from 0 to 4. Okay? Let's say I will provide you the simple problem. Anyone can give you as well. Now you can solve it via the manual method also. You can apply one simple for loop for I in range, go until the value of, let's say, 5. So by default, it will start from 0, go until 4. And inside that, you can write a logic of squaring. That will work best. That is power of 2. So you can say, you can take one list, maybe you can store it in a list 1, and then step by step you will keep on just sharing the value of I to the power 2 like that. And then you can finally print that list 1. That's how it will work, usually in a layman term. But when I'm talking about a list comprehension, you can do this in a single line also. How is that possible? You can say, okay, I'll try to create one squares list. Okay? Inside this, I will first of all give the logic of squaring any number. So what you're supposed to do, you will say number to the power 2. This will give the number, power 2 will give the square of any number. Then I will apply the loop as well for number in range, let's say 5, because I need to go until 4. So 0, 1, 2, 3, 4. Done. Only with this single line, the task is done. Initially, I was performing the same task via multiple lines. And the similar thing, in a more concise manner, in a more readable manner, I can do via the concept of list comprehension. This is something that we call as list comprehension, where initially you're writing a logic of whatever you want to do, then you're applying a looping on top of this. What you can do, you can simply print squares now. What is happening? You are getting a square of every number from 0 to 4. And this is what I want, right? List of squares of every number from 0 to 4. Similar to that, you can apply a concept of list comprehension to calculate the ratio value. So what is the logic to calculate the ratio? Just write first that part. You will say
Profit by weight of
profit
I.
by weight. Simple. Profit by weight. Now you will say, you will apply one for loop. You will say, go and get every profit and weight in. Again, I am using one more interesting function here, zip of profit comma weight. Anyone who is aware about this zip function in Python? Anyone
Yes,
who is
it
aware
pairs
about
up.
this zip function? Yeah.
It pairs up the lists here. So I mean, that's what it does, right? Like
Correct,
kind
correct.
of like a tuple.
Let me give you again a simple illustration of a zip function, and then again we will discuss further. Very interesting function again. At any point of time, let's say you want to merge two lists and want to get the output as in the form of a tuple. For example, if let's say I will be having list 1, which is 1, 2, 3. I will be having list 2. Let's say, what I would say, let's say A, B, C. Now what I want is, I want 1 and A together in a tuple. I want 2 and B together in a tuple. I want 3 and C together in a tuple. So the best way to do that task is, you will say zip. And here you can apply zip function with respect to you will pass the parameter as which two values you want, list 1 and list 2. Now if I'll say for the values available in this zipped, print those values. What will happen? Let's see. Can you see? The zip function automatically will take one value from list 1, one value from list 2, make it in the form of a tuple, return to you. Second is 2 comma B, third is 3 comma C. So what I'm saying in this case, in my code, take one item from profit value, one value from weight value, and do it the profit by weight for that. For every profit and weight, it will make a tuple of profit and weight value, and then do the calculation for profit by weight. That's what I'm trying to convey here. Is this clear till so far? This is the first step which we have to do. This is the first step which we want to do. Profit by weight calculation is done via this. So here we have used the concept of list comprehension. The same thing you can do by writing multiple lines of code. You can apply one single for loop. Inside that, you can write a logic. That will also works fine, but this is a more cleaner way to write a code. Second step, I want to sort the ratio list, which I will be able to get at the end of this code running part, in the decreasing fashion, right? In the decreasing order. This is the task number 2, which we just now have discussed. For that, I'm directly using the function objects.sort. What value you want to sort. That's where, again, I'll try to use one interesting function called as lambda function. How many of you are aware about lambda functions in Python? Again, another way to write a concise code. Lambda functions in Python. How many of you are aware? Anyone who can let me know? What is the meaning of a lambda function? Very, very important function which I believe everyone should know. Lambda
It can take any
functions.
number of arguments. It can take any number of arguments, but has only one expression I think
No. Any other answer? Lambda functions are anonymous functions.
a function without a name.
Yes. Anonymous meaning that any function where the naming is not there. Okay? Anonymous functions. Usually in Python, we define any function via def and then function name, then whatever parameters we have. Let's say if we have any task which can be done in a very simpler manner, right? There is no need to specify a very separate function for that. Maybe I'll give you a way to add two numbers. You can do by defining a function like def sum. You can take parameters x and y. Inside that, maybe you will write a logic of x plus y, something like that you will do in a layman term, right? This is how usually things will happen. But when I'm doing a simpler task, that is not a good way to write a code. If your statements are very less in a definition of a function that you're referring. The better way to write a cleaner code, a better code, is to apply a lambda function in Python. For example, I want to add two functions, right? So what I will do, I will say add, that is my variable name or function name in a way which I want to specify. Inside that, the way to define lambda function is lambda keyword, then the expressions, parameters, which you want to define, colon, what you want as an output, what thing you want to return as an output. You will say x plus y because I want to add two numbers, right? This is the thing which I want to do. So simply now what you can do, you can say print, add, and here you can pass the parameters. For example, I want to add 5 and 7. So if you run this, you will be able to get the answer. So this function is doing the same task which you will do via defining a proper definition of a function. The only thing is, it's a way to write a cleaner, concise code. See, whenever you're writing a code, the better developer would be the one who can do the same task by writing a very small lines of code. The code will be more cleaner. If anyone will see your code, they will be able to get an idea of whether you are a good developer or whether you are just a moderate average developer, right? Just by looking into your code base itself. So these kind of functions, for example, lambda, zip, list comprehension, map, filter, reduce, just check it out in Python. These functions are very performant, very giving a very good accuracy, as well as internally they are working in a way to give you a most optimized result, as well as the major advantage is that you will be able to see a cleaner code. You can do the same thing by writing a multiple lines of code, but if you can do via a single line, why not to do that? If the complexity is same, Okay? So what I will do, I will say key is equals to, in my objects part, lambda, my expression, what value I want, I. The thing which I want to do is on ratio of I, right? It will take I value 0, I value 1, I value 2, I value 3, because in the objects is a list where I values start from 0, will go until the value of n minus 1. So it will take corresponding to that value, what is the ratio which I have, and it will try to sort it out because we have applied a sort function. Now, by default, when you apply a sort function in Python, it will sort your data in the ascending order. But what I'm looking for is to sort data in the descending order, in the decreasing fashion. So we will use one parameter called as reverse. By default, it is false. Once you make it true, what will happen is it will sort your data in the descending order, in the decreasing fashion. So again, within one line, second step is also done. You can write the same thing in a multiple lines of code as well. But already the logic is too much. If you write a bigger code, people will be afraid, right? What you are writing, right? Even though the things are very simple, very easy. Make sense?
Priya, now
Yes.
object will contain the ratio, is it?
Correct.
The list. Before
The
it was
ratio
just
in the decreasing fashion.
Decreasing fashion. Before it was just profit, is it?
Correct.
Okay.
When you initialized, what was the objects containing? Not profit. See this
I mean,
carefully again.
1, 2, 3, 4, something like that. Yeah.
Yes, you're saying length of profit. So this length of profit number will come out to be 7 in our case. Then you are saying range outside that. So range will take your number from 0 to n minus 1, which is 6. You are creating a list for that. So 0, 1, 2, 3, 4, 5, 6. Now in that, you are trying to store the ratio in the decreasing order inside the objects. Is this fine? Last task is what? To do the or to take the objects sequentially, decreasing the net weight and increasing the profit depending upon the conditions. Now, what are those conditions? You will let me know. Can you? Okay, I have done first task, second task for you all. Can you do the third task for me? Third task is to just pick up from the objects step by step. Just now we have seen, right? Update that fractions of I value with 1 if you're taking a whole object. Increasing the profit, maximum profit variable, decreasing the capital M value, and then finally returning the max profit and the fractions list at the very end of the code. Can you do that? I have shared you the file and I think all changes are saved. You can copy this code and below you will write the third step. That's it. Nothing big I am asking from you. I didn't tell you to write the code from the scratch. I have helped you to write. Now to the third step, I think it's very easy for you to write. Can you write it down and share with me the code? I will copy it from your code and see where you are going wrong. And if everything is great, the code will work fine. Can you try, everyone? I'm giving you 3-4 minutes of time. I think that is more than enough to write a code. Let me copy his code, what he has done. Let me copy. So n is length of profit. ठीक है. Max profit is equals to 0. Makes sense. So for I in range n, if weight of object of I is less than equal to m, decrease the value of m, make the fraction value as 1. Fraction of objects of I. Fractions of objects of I. Objects of I.
We are sorting the like so that's the
Yes.
index of the object, right?
So what
Like
your
in
objects will contain? It will contain the
index, the sorted index of the objects. Like say initially whatever the object ranges were, so it will contain the sorted index, right? Like the maximum, let's say the
yes,
5 was the
correct,
maximum.
correct. So you
Yeah,
are
so
using that index value, decreasing the
yes,
value of m, making the fractions value as 1.
but in the else condition, it will be just that we are calculating the fraction. And
Then breaking
I
it
mean,
out.
fractions of objects of I is just that particular value, or weight of objects of I is that a particular value of their object. Like when we are sorting the objects array, what is objects array initially? It's 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's say after sorting, what will happen? It will get sorted according to the profit by weight ratio. So what
Correct.
would be the result of that? Something like whatever, let's say 7, 3, 2, 1, whatever. So when you say fractions of objects of 5, you say fractions of 3 or fractions of 7. Like accordingly, we will add, right? I mean,
Let's try to run
I mean,
this.
maybe it's too roundabout.
Makes sense. So basically, what he has done is that um, one other way can be, which we can do, is we can directly refer that objects array rather than referring it again and again.
Yeah. Roshan has done that way, I think.
Like, yeah, correct. Roshan has done. I haven't checked this code. So either, yeah, this is the correct way, or the way Arjit has mentioned is also correct. One and the same thing, but yeah, okay. Synthetically, it will be not same. So let me write it down. So what I'm saying is this one is fine. Either this way is fine, or you can do via the logic Roshan has done. Basically, what you can do, you can directly access the objects index that you are scanning. You are seeing that if the weights available in I is less than equals to the value of capital M, what you're supposed to do? Same thing. Just decrease the value of capital M by M is equals to M minus equals to weights of I. So you have reduced the capacity. Is the spelling is wrong? Okay, it's a weight array. Okay. Another thing which you will do is you will try to add the maximum profit. So whatever thing you have initialized maximum profit, which is equals to your profit of I array. And then your fractions of I will be equals to 1, right? So this is the thing which you can do. Otherwise, in else case means we reach to a point where we can't directly pick up the complete object that we have. For that case, what we can do is we can say our value of capital M will be 0, obviously, in that case, and the max profit value will become whatever be the max profit we are getting plus equals to what is the value of profit of I into the value of capital M divided by the weight of I that we are having. And our fractions of I in that case will looks like what is the value of capital M divided by what is the value of weight of I. And in that, once it is done, we can break. There is no need to further go ahead with respect to the other objects that we have in the objects per se. And then we can simply, after returning out of the for loop, what we can do is we can simply return two things. What is that? Max profit and fractions. So what he has done is he has mentioned this objects of I, taken that index value inside this and then writing it down the weight of that. That is making sense, but it might be confusing for someone. But if you can write like this, directly picking up the value which is available in the indexes as in the objects indexes, which is in the sorted fashion, then directly jumping towards that and doing the stuff. Let's try to first of all check it out. Any question anyone is asking? Yes, Arijit,
No,
you're saying
so
something?
what I was saying was, so I defaulted to this when I started with for I in Ranger. I should not, I started with that and then I just went ahead with
Yes.
that approach. If I started with for I in objects, I think that would be okay.
Although in terms of complexity wise, nothing will make much difference because it will remain same. But yeah, for the cleansing part per se,
Yeah.
this second one
And
is much better.
yeah, for legibility and understanding.
Understandability, yeah, correct. Any doubt, anyone? What we have done here, this is the correct logic. Even that is also correct. One and the same thing actually, just the way to access the values is different. That's it. Any doubt, anyone? So for the third part, what we have done is, see what is available in the objects part per se. If you can see, we are trying to sort on the basis of the ratio part, right? Our value of I in the decreasing order. So what we will be having is the out of the 0, 1, 2, 3, 4, 5, 6. Now in the form of the decreasing fashion as per the ratio, the indexes. We are trying to pick those indexes and comparing that corresponding weight value with the value of M. If it is smaller, directly we are fetching it up, decreasing the value of capital M, increasing the maximum profit, and making the value of fractions of I as 1. After some point of time, when you left with this entry, like here we are left with 9, right? Do you remember the case when we are left with 9, right? Which is not lesser than the, the net capacity is 9, which is somehow smaller than the weight that we have for the current object. In that case, it will go to the else condition. Increasing the profit, how it will increase? The profit of I, which we will be having, already we will be having maximum profit plus profit of I into capital M, because we're taking a fraction. So fraction only will be multiplied with the profit. And then fractions of I will become M by weight of I. Then we will break. Why we are breaking out of this particular thing? Because for the upcoming objects N5 and N1, I don't need to go. Why? Because I know that the value of capital M is now 0. So I can't take more objects now. So why there is a need to go to further for the other indexes that we have, right, in the objects? That is where we will break, and we will simply return the value of the max profit and the fractions. By default, we have initialized our fractions with the 0 itself. So remaining 2 which are pending will be left with the 0 value itself. That's why if you can see here, the answer is same which we are getting 337.5, and the fractions value which we are getting is 0.911011. And I think it's correct, right? So if you will just check it out, with respect to 0 and 1 value is 0. With respect to 2, it will be 0.9. With respect to 3, it will be 1. 4, it will be 1. 5, it will be 0. 6 will be 1. 7 will be 1. So they are getting the same answer here as well. Just verify. Is this fine for everyone or any doubt you have? Anyone? Interesting, right? So while writing this code, also we have understood the concept of list comprehension. That is a good thing. That is the way to study as well. It's called reverse engineering. Like you don't know something, then you start writing the code, you get to know some new pointers, then you understood that, and then you went again to write the further code. Right? That's how maximum portion of the content you will be able to learn when you go to the industry, because everything you don't know. It's something you came up and then you will be like, I don't know this stuff. You will learn from somewhere, then you went back and try to move ahead with respect to that point. This is how you will get a maximum learning in any of the code. Right? Shall we move ahead? Any doubt? Acha, we have discussed although. So what is the time complexity of this approach? Overall, it will be big of n log n. So you can see this list comprehension is somehow using the for loop only, scanning the entire list that we have, entire profit by weight calculation is going on. So it will be n. Sorting is n log n, although we are using a dot sort function, but in the last class when we were discussing about divide and conquer approach, I told you, right? Even though you are using the inbuilt functions in Python, don't consider that it's a constant time. Internally, the algorithms are working. So it will be n log n only. And then it's a single for loop. Inside that, you're applying if else condition, and then finally you're returning. So again, it will be n task. So n log n, n combined together will give you n log n as the complexity. Any doubt in the very first application of greedy algorithms? Anyone? Any doubt, anyone? Or shall we move ahead? To the next application.
Can we take a break for like 5 minutes?
We will not do too much. The code implementation will not do today. Just the problem statement discussion we will do, and then we will wrap up the session. Don't worry. Okay. By 10:30, I'll try to wrap up. So just try to understand the logic. As a task, I will give you the implementation. That's it. So I think that will work, right? Or do you want still that break? Everyone? Shall we go ahead, or 5 minutes break still is
Yeah.
required?
Let's complete them.
Okay. So here, if you will be able to observe, the second application which we will be focusing on is the job scheduling. Listen this problem statement pretty well, because the approach we will discuss today, implementation is the today's task which you have to do. I will also attach a lead code problem also for the same, but if it is not there, I don't remember exactly. It might be there, it might not be there. Just do it in the collab if you want, but I want the solution for the same. Okay? So let's discuss the problem statement first. Job scheduling. What this problem statement says. We will be having a jobs listed. Let's say we will be having 9 jobs. And for every job, you have been provided a profit and a deadline for the job to be done. So you will be having J1, J2, J3, J4, J5, J6, J7, J8, and J9. So this is the jobs that we have. For every particular job that you have, you will be having a profit and you will be having a deadline for that job. Okay? Profit is given, deadline is given. So I'm just writing few numbers here. Profit is 55, 65, 75, 60, 70, 50, 85, 68, and 45. Deadline is 5, 2, 7, 3, 2, 1, 4, 5, and 3. So we will be having 9 jobs. For every job, a profit is given, a deadline is given to complete that job. Now, what is the constraint? Anyone who can guess? It's very easy. What could be the possible constraint given to you in this case?
Maximum number of jobs. Like we want to complete the maximum number of jobs with the maximum profit, you can say.
This is not the constraint.
Okay.
Constraint would be that every job should be finished, like whatever jobs you will pitch up, within a deadline. Roshan has correctly said. So what is the constraint is? Constraint is to get jobs done within a deadline. You can't exceed the deadline within the given deadline. It's kind of you are doing a project, and every project in the industry will have some specific deadline, right? You can't go beyond that. You can't say until or unless some emergency happened, then also manager will not listen usually. But still, Any rarest of the rare scenario they might consider, but usually we can't go beyond the deadline, right? Where we have to deliver the results to the clients. So this is the kind of a constraints which we have to follow up. Now, what is the optimized solution which you have to deliver is, you need to pick up only those jobs which will give you a maximum profit. Again, see, maximum word is coming into picture, right? That's where you need to think about the optimization logic. So always remember that, in any lead code problem also, again, it's an intuitive sense that not 100% it will be going, but 90% of your problems will be like maxima or minima finding. In that case, think over the greedy or DP itself, right? So in this case, again, if you will be able to observe, we need to pick up those jobs which will specify under these constraints, means will be done within the deadline. That's the first thing, and will give me a maximum profit. That is the thing which we have to focus on here. Is that correct? Clear, everyone? How should I approach to this problem? Any idea, any logic which you can give to me?
So we can start with jobs with the minimum deadline.
Okay.
Like,
Okay. So you are saying that if a job is having a deadline of 1, from there you will, means you will take for sure J6 as the first go. Like that?
that's one approach, but
Okay. Any other thought process anyone is having? So what
like
Arjit is saying
multiple.
that he will prefer to go for the minimum deadline. Maybe he will try to sort the data of deadline in the ascending order, and maybe whichever is having a minimum deadline, he will pick up that and finish it.
Also, we want maximum profit. So I think we can go with the multiplication of the deadline with profit.
Okay.
Mm,
Any other answer? Any other thought process? Divide profit by deadline. Interesting. Any other thought process?
Priya, can you please repeat the problem once? I mean,
So the problem statement is that we will be having 9 jobs. Okay. And they are saying that for every job, I will provide you a list of profits plus deadline to finish that job. The constraint is that you cannot go beyond the deadline. For example, if let's say J3 job is done in 7 days, so you can't go beyond 7 days. Like you cannot take 8 days, 9 days, 10 days to finish that. One thing, this is the constraint. Now, given these entries that is available in your screen, I'm saying which jobs should I pick up so that I will be able to get the maximum profit. Which particular jobs I will pick up so that I will be able to get the maximum profit. That is the ultimate thing which I'm looking for. So one possible solution, Arjit suggested that we can take a minimum deadline thing. Then he said we can multiply profit and deadline. Then Roshan said we divide profit by deadline. Any other thought?
We should focus on maximum profit.
Okay, maximum profit we should focus on. So she's saying that try to sort the data as per the profit in the decreasing order. And whichever is having a maximum profit, pitch that one first. That will give the maximum profit of the jobs. Is that so?
probably we need to figure out which is the deadline which is highest, and then use divide profit by deadline and add up to that number, so that if
Correct. That's the most optimized version of whatever approaches you guys have suggested here. See, think over it. The maximum deadline here is 7, right? So what I can do is I can create a list or array. Okay. See this. What I can do is I can say It is 1, it is 2, it is 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. Okay? Now what I will do is, I will say that, okay, whichsoever is having a maximum deadline, which is 7, that task I will do at the 7th day. Why to go for first day, second day, third day, fourth day, fifth day, sixth day? I can have a deadline of 7. I can't exceed more than 7. So J3, I will try to finish at 7th day. Then I went to 6th deadline. I saw, as per the 6th per se, do we have any competing factor? As per the 6th per se, do we have any job which can be listed? No job, right? And I can't do any job which is having the deadline of 5, 3, 4, 2, 1. It means J6 will remain empty. Do you guys agree with me? So what I'm doing is, I'm starting from the back, from the maximum deadline, and listing it down which jobs I can do on which day. And that will give me the maximum profit. So as of now, I have picked up only J3, which will be done on the 7th day. Maximum profit will come out to be 75 for this. I'm going back 6th day. I cannot do any job because the deadline is not 6 for any job. It will be either 7 or it will be then 5, 4, 3, 2, 1. So I cannot do any job of 5 on 6th day, right? That's the constraint. I cannot violate that. I'll go to 5. I'll go to 5, 5th day. Now I will check 5th day. This is the competitor. This is the competitor. Out of these two jobs, which job I should pick up?
J8.
J8. Why? Because J8
Maximum
is having a
profit.
maximum profit. Do you guys agree with me? J8 is having a maximum profit. So what I can do is, I can say J8 on 5th day. Then I went to the 4th day. Now on 4th day, my competitor will be, always remember, 5th is the deadline. I can do on 4th day as well, right? So either I can pick this job or I can pick this job. Two people are competitor on 4th day. Which job should I pick up? J1 or J7?
J7.
J7, because it is having a maximum profit. So I will pick up J7. Again, I went back. Now on 3rd day. So this is exhausted. This job is done. This job is done. And I think this J8 job is also done. Now I went to 3rd day. On 3rd day, either I can do this job or I can do this job or I can do this job. Which job should I pick up?
J4.
J4. Why? Because it is having a maximum profit. So on 3rd day, I will go for J4. So it was done. Now when I came back to 2, this is the competitor. Either this, or this, or the last one. These jobs are done. So now which job should I pick up? On the 2nd day, there are 4 possibilities, either to pick up J1 or J2 or J5 and J9. Which job should I pick up?
J5.
J5. Again, check the profit part, right? Now only 1 day is left. It's interesting. So J5 is also done. Only 1 day is left. Only one deadline, one job is this, or this, or this,
J2.
or this. I'll pick up
J2.
J2. So can I say that these, if I'll try to work according to these jobs, I will be able to get the maximum profit, in which is for J1, I will be having, J2, I will be having a profit of 65. For J5, which I'll do on second day, the profit is 70. For J4, which I'll do on third day, profit is 60. J7, the profit is 85, which I'll do on fourth day. J8 is 70. And last one is 75. So total will be 65 plus 70 plus 60 plus 85 plus 70 plus 75. Whatever be the number you will be able to get, that is the maximum profit we will be able to achieve. Anyhow, this is not the thing I want you guys to print. I want you guys to print the sequence order of jobs which I will do. So as an expected output, I want a list where the output should be J2, followed by J5, followed by J4, followed by J7, followed by J8, followed by one empty space. Nothing is there in my solution, followed by J3 as the last part. This is the expected output from you all. So if I have to write a pseudo code for this, how can I write? But before that, is the problem statement is clear and the logic is clear? How we will be able to get a job sequence so that we will be able to achieve a maximum profit of the jobs? Will that make sense to you all, whatever I have said here? So what we are doing is intentionally, we are not starting from the starting of the array. We are starting from the back and we are trying to figure it out that which is the minimum value, either this index number or the deadline number that we have. Whatever be the minimum that we are trying to take as an index, and we'll try to figure it out from that index itself. Is this clear to everyone what I'm saying here? So what is a task which we're supposed to do in this case? How will you go ahead when you're writing a code? How will you go ahead while writing the code?
First, we should probably zip a profit and deadline, sort by the deadlines, sort by deadline and profit, sort by profit and deadline.
So if you can sort by profit itself. Okay? Sort by profit itself. What will you able to get? You will be able to get as the very first go, the value will be J5, right? So you will be able to get J5. What is the profit? 70 and deadline is 2. After that, you will be able to get the next value in the decreasing fashion. I am saying the next value will be 65, right? J2, 65, and the deadline will be again 2. Okay, both of them is 2 deadline. Okay. Next value will be 75 is the highest, or yeah, J3, 75, deadline is 3.
Actually,
Then,
85 is the highest.
oh, 85 is the highest. Let me just remove it then. So start from this J7, 85, 4. Then J3, right? 75 and 7. Then J5, 70 and 2. Then J2, 65 and 2. After that, J4, 60 and 3. Then, not 60, 68 is pending. J8, 68 and 5. J8, 68 and 5. Now it is fine. Any other thing pending? No. Now I think 55 is there. J1, 55 and 5. Then J6, 50 and 1. And finally, we will be having J9, 45 and 3. J1 is done, J2 is done, J3 is done, J4, J5, J6, J7, J8, J9. Done. So I have tried to sort my data as per the profit value. Okay? Now what we can do, we have a profit, we have a deadline. Now I know maximum number of jobs or maximum deadline which we have in this case is 7. Okay? So what I will do is I'll try to create 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6. So whatever be the maximum deadline is you have, which is 7, you will create a array corresponding to that with respect to 7 minus 1 from 0 to n minus 1 or m minus 1, whatever be the deadline you have. Okay? Or d minus 1. Now, how will you start your progress? You will start from the starting. In the second step, what you will do? Think over it. In the algorithmical side, you will say 4, right? 4 is the deadline. So what you will say? What is the minimum value? In the loop, you will say, what is the minimum value of the 6, which is the highest index you have, comma, current job index. What is the minimum value? 4. You will go and insert J7 in the 4th index. Am I saying it correctly? Because this particular J7 job will be inserted either at 4, or you will start your loop for I. If it is empty, you will insert in 4. Otherwise, you will go -1, -1. Means you will apply a backtrack loop. Either it will be 4, or it will be 3, it will be 2, it will be 1, it will be 0. Depending upon whether you have an empty space or not. For that, you can do one thing. You can take one Boolean result array, and maybe result of I, which will be initially initialized with false. You can check whether it's false initially. Yes. If it is false, make it true after inserting a job. So this result of I array will take care of whether already a job is available or not. Why I am already saying all these points? Because I want you to do the implementation. So at any point of time, if you will feel like you're not able to understand, please let me know. So initially, you will be having all the values as false. So whenever you have inserted any job here, you will make it true so that you will get to know that, okay, this is already filled up. Go to 3. Then if it is already filled up, go to 2, 1, 0. Because any job which is having a deadline of 4 can be done on a 4th day or 3rd day or 2nd day or 1st day. Okay, one thing which we are doing wrong is it should be at 3rd index. So you should see a minimum of 6, 3. So it will be whatever be the index value you are having, which is 4 minus 1. Correct? Index number will be -1. I hope everyone knows that. This will be maximum job, which is 7 minus 1. So what is the minimum value out of these two? That will be reported in the 3rd index. So what I am doing in the second step, again, I am repeating. I am starting from the very first job, seeing the deadline. It is 4. So I am just checking that what is the last index value I have? It is 6. My job deadline is 4 minus 1, which is 3 as an index number. In terms of position, this is the 4th position. This is the 4th day. But as per the index number, it is 3 minus 1. So you are comparing the two values, index value and the current deadline value, whichever is minimum. From there, you will start doing the insertion. Because you cannot exceed the deadline. Either you will go on this 4th day insertion, or you can insert on third, second, first day. So you will try to apply a backtrack loop from extreme right to left. This is how the loop will work here, not from left to right in the normal case that we usually do. Then we will move ahead to the next job. Deadline is 7. So I will see again, minimum of this deadline minus 1, which is 6, comma, extreme value in our index is 6, which is 6 only. So you will directly go to the 6th index and insert J3 there. Next particular value is J5. Index number, position is 2. Index number will be 1. Minimum of 6, 1, it is 1. Already, by the way, you will make it true again. It is space is available, J5 will be done. Moving ahead, next job is at position number 5, means index number 4. Index number 4, you will go and insert J8 here. Next value, 2. Matlab, index number will be 1. This is interesting. Think over it. Index number will be 1. You will go. Now, here, there is already job is available. So you will go ahead because you're applying a backtrack loop for I equal to 1 to 0. So you will go to the 0th index and insert J2 here. Next value, 3. It means that you will go to the 2nd index and insert it. Then next value, 5. This is again interesting. You will go to the 4th index. You will go to the 4th index and insert J7, J1 here. But already you will be having a jobs true. You will go to the 3rd index, already job is there. 2nd index, job is there. 1st index, job is there. So you will say that this job I cannot fulfill. Similarly for J6, you will go to the 0th index, already job is there. You cannot do that job. J9, already at 2nd index, job is there. You will again backtrack. 1, job is there. 0, job is there. So you can't do this job as well. So in a way, the answer should be J2. You can see the answer is same. J2, J5, J4, J7, J8 and J3. In between, there is a blank space. Does that make sense what I have just now said here? Is this clear to everyone? So only 2 steps. First step is to sort the data in the form of a profit. Second step is to take your for loop from the back side, from the minimum of the extreme index value, comma, the deadline value minus 1, because you are dealing with a zero-based indexing. Whatever be the minimum, from there you will start and go until the value of 0. If the space is available, you will insert the job. If the space is not available, you will go back, until you find a specific space to insert the job in the given list. Finally, what you will return as an answer, or what you will print as an answer, is the jobs list. So again, if I'll ask you, what is the complexity of this algorithm? Sorting is going on, so it will be n log n. Then you are just trying to take it in a sequential manner, applying a for loop, right? And depending upon the condition, you are doing that task. So just check it out whether this requires for you a single loop or a for loop, depending upon how optimized you are doing. And then printing will not take much time. It will be just an end task. Now, this second step will depend on each and everyone's logic, how you are doing that part. So looking forward to this code, and then maybe in the next session, I will copy the code of yours. First of all, see that whether it is correct or not. If the logic is properly fine, we will move ahead with that code itself. Otherwise, I'll do the implementation at the very end. Is this clear? So if you are still here, I hope that you really like the session, because it's a very long session and it genuinely requires a lot of patience to listen each and every bit of stuff. And I believe that you are really enjoying that part. That's why you are still here. So please do let me know if you are still here in the comment section of this video. And I hope that you gain a lot of insights with respect to the greedy algorithms now. Please make sure that you will go and check out the page of a SQL bootcamp. And if you are interested, coupon is going on for the 2 days, that is available until 29th night. So please make sure that you will utilize that, and I'll see you all very soon in the upcoming videos as well.